जेई एडवांस के एग्जाम में पूछे गए क्वेश्चंस यूजुअली ओलंपियाड के क्वेश्चंस की तरह नहीं होते, रादर वो ज़्यादातर सिंपल फैक्ट्स के कॉम्बिनेशंस होते हैं। मल्टी कॉन्सेप्ट्स क्वेश्चन, बट कॉन्सेप्ट्स जो बहुत डायरेक्ट और सिंपल हैं। आई रिपीट, सिंपल कॉन्सेप्ट्स के कॉम्बिनेशन। ऐसे ही एक क्वेश्चन को आज हम करेंगे अपने इस वीडियो में। ये क्वेश्चन मैंने अपनी पर्सनल टीचर सीरीज बुक से डायरेक्टली पिक किया है, हीट एंड थर्मोडायनेमिक्स के ऊपर बेस्ड। ये क्वेश्चन कुछ ऐसा है। A hollow sphere of inner radius r1 0.25 meter and outer radius r2 0.5 meter contains 20 kg water at 0 degree Celsius. This diagram shows a hollow sphere. Inside this, there is 20 kilogram of water at 0 degree Celsius. It is placed in a heat reservoir maintained at 200 degree Celsius. Outside everywhere, just a minute. Outside this sphere everywhere, the temperature is 200 degrees Celsius. The conductivity of the material of the sphere is given. Heat capacity of the sphere is negligible. The specific heat of water is given. Latent heat of vaporization of water at 100 degrees Celsius is given. Assume no change in boiling due to creation of steam and rise in pressure. Time after which water in this cell will be at 100 degrees Celsius, and time after which there will be only steam inside the shell is given by. So, just to make it more clear, I must stress upon this fact that conductivity of the material of the sphere is given, but at the same time it has been given that heat capacity of the sphere is negligible. What does this statement mean? Heat capacity of sphere is negligible means even if temperature of this sphere rises, it will absorb negligible amount of heat. If its temperature falls, it will release negligible amount of heat, isn't it? Then the question says, assume no change in boiling point due to creation of steam and rise in pressure. Once the water begins to boil, once it gets converted into steam, the pressure in the chamber will rise, it will change the boiling point. But the question says, ignore that. That means the question is trying to tell you that keep the question as simple as possible. One thing which has not been stated typically here, that is also not stated in most of the JEE Advanced question. That means you have to assume that the inner wall or this entire chamber is at one temperature. I mean, if the temperature here is 98, then the inner wall is also at 98. When the temperature here is 100, this whole thing is at 100. That means you have to assume that temperature is uniform inside this cavity, and outside obviously the temperature is uniform at 200 degrees Celsius. I'll get out of the screen for a moment. You can capture the question and try it on your own before you look at my explanation. Please capture the question and give it a try on your own. The question, I'll explain basically how you have to proceed. The typical thing in this question is to understand that rate of heat flow is not constant initially. The outside temperature is 200 degrees Celsius, and here water is at lower temperature, starts from 0 degrees Celsius. So heat actually starts flowing into the sphere. It starts warming the water. So what is the rate at which heat is flowing into the water? It is not a constant rate. Many students will make this mistake. I have seen them making this mistake. They assume that temperature here is 0 and here is 200, so this is the rate of heat flow. No. Once certain amount of heat enters into this chamber, water temperature will become 10, 20, 30, 50, 60, 100 degrees Celsius. So when the temperature here is rising, the rate of heat flow will reduce, because the rate of heat flow is proportional to temperature difference. Rate of heat flow per second, the amount of heat entering into the chamber, into getting into water, is proportional to the temperature difference between here and here. And as you must have studied, rate of heat flow is basically temperature difference divided by thermal resistance. So first requirement is that you need to find the thermal resistance of such a spherical shell. I don't know whether you remember it or not. If you remember it, it's fine. If you don't remember it, then you have to take elements in shape of shells and integrate to get the thermal resistance. Once you get the thermal resistance, you know the rate of heat flow when temperature here is T. This temperature is variable. So actually delta T is not a constant quantity. It is 200 minus T. I am assuming that T is temperature here in degrees Celsius. So 200 minus T is the temperature difference divided by the thermal resistance. Thanks God. This thermal resistance is constant. This is property of this basically sample of material. ये इसकी प्रॉपर्टी है और उसका टेम्परेचर से कोई लेना देना नहीं बिकॉज थर्मल कंडक्टिविटी इज कांस्टेंट according to the question. So rate of heat flow is actually decreasing with passage of time. This is the most crucial thing that you have to observe in this question. So when the temperature here is T, in a small interval of time dt, the amount of heat that will enter into water is given by this. I have multiplied both sides by dt. This is the amount of heat that enters into water in a small time interval dt. When heat is added, the temperature of water rises from T to become T plus dt. So the mass of water m into its specific heat S into rise in its temperature. This is the amount of heat that water has absorbed, and it should be equal to this much. So basically I have solved the question. No, not at all. Now you need to do the necessary mathematics to know how much time it will take for temperature of water to change from 0 to 100 degrees Celsius. After that, once the temperature becomes 100 degrees Celsius here, that means water starts converting into steam. The temperature becomes constant. Now there will be no change in temperature because addition of heat causes water to convert in steam. It is at its boiling point right now at 100 degrees Celsius. So once the temperature becomes 100, it will not become 100, 100, 200, 203 unless the entire water converts into steam. So after that point, the rate of heat flow will also become constant because this is 200, this is 100. So now rate of heat flow is constant because this delta T is constant, 200 minus 100. So once water is at 100 degrees Celsius, the rate of heat flow becomes constant, and you can calculate the required time for the entire water to get converted into steam. I'm not solving the question, but yes, I'm leaving you with the solution, and I have copied the solution from the book itself, and it will follow after this. So if you have not been able to solve this, if you do not know, if you want to know what is the correct answer, wait for next 30 seconds, and here you get the solution. Thank you. Goodbye.